Hello everyone, welcome to the Somnia Developer Education Series, Somnia 101. In this session, we are going to learn about Portfolio Chainlink VRF services now available on Somnia. What is VRF? A verifiable random function is a cryptographic method of generating random numbers along with a proof that the result was not tampered with. How does this work? Basically, you request a random number from a VRF service, and then a VRF Oracle network, in this instance, Chainlink, which is made available to us via the Portfolio service, generates a random value off chain along with a cryptographic proof. The proof is then verified on chain before the value is returned to your smart contract. This ensures tamper-proof randomness and publicly verifiable results where the outcomes are fair. This is a visual representation of how the VRF solution works. So you have the Somnia blockchain, and then the Portfolio Chainlink VRF service, and then the user. The user makes the request via the Portfolio VRF service, and that is finalized on chain, and then a response is returned via the service back again to the user. As I mentioned, this service is available on Somnia via the Portfolio Chainlink's VRF service. So it allows developers to securely request random numbers in a tamper-proof and auditable way, and it is ideal for gaming, NFT meets, and lottery solutions. So now developers are able to build 100% on-chain games on Somnia. Requesting VRF data using Portfolio Chainlink service relies on two methods. First, we have the subscription method, and then we have the direct funding method. How do these work individually? For the subscription method, the Chainlink VRF receives funding from the subscription account. The subscription manager then lets you create an account and prepay for the use of the VRF request. So you have a subscription manager, and then this enables you build an experience where your users do not have to pay for the service themselves, which is what is then made possible with direct funding. So direct funding method doesn't require a subscription account, and it is very optimal for one-off requests for randomness, and also it works for applications where your users are the ones paying the fees to access the VRF solution. Now, having set the background, let's jump right into the code. We are going to be writing our smart contract using the Remix IDE. This is so that we can test the smart contract immediately by deploying it to the Somnia network and then using the Remix playground to test the deployed functions. So that said, the first thing that we need to do is to create a random request smart contract. So the random request number, it's going to be a simple smart contract that would deploy an instance of the verifiable random function wrapper, and this will enable us access all the methods that are available in the wrapper. This smart contract is going to have 5 different methods, and these methods would enable us request a random number, fulfill the randomness, and then get the latest random number that was deployed. And of course, we want to be able to tell the price for the particular requests before sending. Please note that this smart contract deployed is going to use the direct funding method for us to interact with the wrapper and then return randomness. This example does not use the subscription method. And we are also going to have a withdraw function to enable us to withdraw any tokens that may be in the smart contract as the owner of the smart. So to start writing our smart contracts, we are going to need libraries that are available to us via the Chainlink implementation of the VRF wrapper, which is being consumed by the Portfolio service and made available to Somnia network. Start our smart contract by adding the license identifier and the version that we are going to use for this smart contract. Before we go on to write our smart contract, there are a couple of imports that we are going to be using, like I already mentioned. I am going to copy those imports and paste them and explain what they are. So we have 3 imports. We have the VRF V2 Plus client, VRF V2 Plus wrapper consumer base, and also the confirmed owner. The confirmed owner is basically a modifier that specifies the owner of the smart contract and ensures that only the owner can carry out very particular or specific functions. The VRF V2 Plus wrapper consumer base enable us to access all of the methods that are available via the Chainlink wrapper, where the service is made to available to us via the Protofire Oracle client. And then with the VRO FV2 Plus client, we are able to um, carry out our calling for a random number by enabling by accessing a specific method which is available in the VRF V2 Plus client that enables us to allow for the payment of randomization using native STT. So, like I did mention, this service, this particular example is going to rely on the direct funding method, and then would request for random numbers using native STT. So, having established that background, we can go ahead and start writing the rest of our smart contract. We need to make sure that the libraries that we have added, that we are going to use throughout the entire smart contract, it's made available to the all the functions in the smart contract by being defined at this point. So we want the VRFV2 consumer base, and of course we want the confirmed owner. So having established that premise, the next thing that we want to do is to add the specific variables that we are going to be using through the smart contract. So the very specific variables that we require are a request ID, and the request ID is used when the user makes a request to the VRF service, and then the VRF service has to fulfill that request. So we are also going to need a fulfilled state variable that's going to tell us whether the request has been fulfilled or not. And then we also want to have the random word generated returned to us. So in this instance, for the latest random word, we are going to be requesting a number of words. And for this example, we are going to be requesting 3 words. You can request 1 word or 2 words or any number of words as you so please. But to have them returned, we are going to be using an array type. And last but not least, as I mentioned, we want to find out if our request has been fulfilled. And this would be a boolean, making it truthy or falsy. So that is set to public. I mentioned a constant earlier on. That is the number of words that we are going to be requesting from the service. In our own case, we are requesting 3 words. So we are going to set it as a constant, and then we are going to have 2 other constants as well. One of which is the number of confirmations, block confirmations that we want to have before the random number is returned. Remember that the request for random numbers is not fulfilled in one call, but rather it is fulfilled in 2 calls. First, a request ID is generated, and then that request ID is used to generate a random number in a future call on chain. So, and we want 3 blocks, which is the number of confirmations to pass before we get the random number returned. Due to how fast Somnia network is, this number could be returned in a matter of seconds or possibly under a second, depending on being finalized on chain at a particular point in time. Specify a callback gas limit. The computation for the gas limit is each word actually costs 700,000 in gas to generate. So that means if you need 2 words, that would be 1.4 million gas, and 3 words, of course, will cost 2.1 million gas. So these are all constants, and we can go ahead and specify the various data types. We are requesting three words, and each word costs 700,000 in gas. The next thing for us to do would be to set up a constructor, because we are going to be initializing the smart contract by also deploying the VRF V2 plus wrapper consumer base to be able to access all the methods available in that wrapper. It's going to take an argument, an address, which will be the wrapper address. The wrapper address, it enables us to access all of the methods available in the Chainlink service via the Protofire deployment. So this is the smart contract of the wrapper. By wrapping around this address with our smart contract, we'll be able to access all of these read operations and also all of the write operation that will enable us to request random words and fulfill those random words. So the code is available here, and then you'll be able to go study it up and learn how it works. But for example, we are just going to, when it's time to deploy a smart contract, we are just going to copy this address and then deploy it as part of our smart contract deployment. So the next thing that we need to do is to write the different functions that we need for our smart contract. So we'll begin with the request random number. This is where we are able to make a call to generate a request ID and then ensure that it is fulfilled, then call the get latest random word. So this does not take any arguments. We can mark it as external. So first, we want to check if there's a pending request by checking that if a request ID has been fulfilled or not. While writing out this particular function, I'm going to be adding events and errors to the smart contract. So let's check first if there's a pending request. So if the latest request ID it's not zero and also the fulfilled state it's not true, we want to revert with an error. So to revert with an error, I want to use the error keyword available to us in Solidity. Now that we have completed our first check, the next thing that we want to do is to calculate the costs of sending this particular request, the cost of requesting for a random number, since we're using the direct funding method. We're going to have a function to get the costs of calling a random number. So the next thing that we want to do is to conduct a second check to affirm that the cost of the request is lesser than the message the value at the time that we make the request, right? And to do that, I have to declare a variable called request price. And I want to set request price to a function that I'm going to write afterwards called get request price. After calling get request price, I want to check that the amount that I will send using message.value is less than the request price. If that is not the case, I need to revert with another error. And then again, I'm just going to define a custom error. I'm going to call this custom error insufficient payment. Insufficient payment is going to take two arguments. That would be the required amount and then the amounts that I actually sent. So coming back to the revert error, I'm going to have insufficient payments. I am going to pass in the message.value on request price. So this will let us know if we have sent enough to cover the costs of getting a random number. To enable us pay for requests using direct funding and native STT, we would have to use the VRF V2 Plus client library. But first, we have to define a variable and then set a data type on it using the VRF V2 Plus client as well. So we have a variable extra args, but it's using the VRF V2 Plus client data type with a method called extra args v1. I want to have it in memory, so we'll set this to extra args v1 and would assess the ability to pay using native payment. Now we'll be able to pay using native STT, but for this data type we have to convert it into bytes. We'll declare a new variable called args. So byte type stored in memory, and then still using the VRF v2 plus client library would access a method called args to bytes. So now we'll be able to request randomness by calling a specific method called request randomness pay in native. So we'll pass 4 arguments to the request randomness pay in native, and that will be the callback gas limits, the request confirmations and numbers are constants, and this args variable that will just declare that will enable us to pay native SCT. And what we are going to get returned when we call request randomness pay native would be a request ID and the amount. First, what we are going to have returned, this is going to be gotten from the request randomness. We want to update the state of the request ID. Sets latest request ID to the request ID that will be returned to us. At this point, we have been able to send a request to have a request ID sent back to us. So the next thing that I want to do is emit an event that will send us the request ID and the amount paid. I'll create an event and call this event, call it request sent. We would also need a request fulfilled event. For the next function will be to call fulfill random words. So for now, we just want to have an event emitted, request sent. We want to have the request ID and then the amount that was paid. So that is our function to request a random number. So the next function that we are going to have is going to be to fulfill the random number. It's been auto generated for us by the code assistant. So it's fulfill random words. We are going to pass it a request ID and then the random bots. Note that it's internal and it's going to be called by the VRF wrapper itself. Once that is done, we are going to do a couple of checks. So at this point, we want to first of all check that the request ID exists and also random words have been returned, and then would update the state of fulfilled, which is a boolean, to true. So what we are going to do is first of all check using require statements. So we have require statements to check if the random words have been provided and request ID has been provided. And then once that happens, one will update the latest return random words variable with the number of random words and then update the fulfill status to true. Now that we have done this, now we are setting that we have our random words being sent back to us. So we want to be able to get the latest random word. We have a function auto generated for us. It's called get random number, and we just want to return the latest random word. But in here, we can quickly do a check using the require statement to make sure that it is already fulfilled. So that function enables get a random number. And remember, we are using the direct call and we have a get request price function that we've not created. So the next thing to do will be to create the get request price. So for this, we are going to use a wrapper that I am going to copy and paste. You can find this in the documentation and simply copy it and update your function with it. And last but not least, we want to enable a withdraw function. Say we have any extra tokens sent into the contract. And to be able to do this, we need to ensure that only the owner can call it, and then we need to ensure that there is token in the contract using the require statement. Else, we should not be able to withdraw. And also, we have to check that this contract is able to receive tokens. And that's it. We are done with our smart contract to be able to request a random number. We have our libraries imported from Chainlink via the Protofire service. And then we have our constants. Remember the callback gas limit. To request one random number will cost 700,000 gas. So for every random number you want to request, if you want to request 5, you multiply by 5. If you want to request 10, you multiply by 10. And we have our functions. Remember I mentioned that it works in two separate calls. First, you make the call to request a random number and it generates a request ID, and that request ID is passed to the fulfill random word function, and after 3 blocks it fulfills it and returns it to you. This could happen under a second given how fast Somnia network is. So we are going to compile the smart contract. It has compiled, and next we are going to deploy it on Somnia. And to deploy the smart contract on Somnia, would pass the wrapper address. So I'm going to copy it. This enables access all of the methods available in the wrapper. You can go ahead and read the code for yourself, right? So that's the ABI. You can see all of the methods available. Paste the wrapper contract address, hit deploy. This smart contract has been created, and there you have it on the left with all the methods available to us. So first, let's check if there is any random number that has been generated using get a random number. There is none generated, so there is no money in the contract. There is no latest requested ID. To request the random number, first we'll check the request price to give us the value that it would cost. So copy this, paste it in the message.value, set it to weigh, and request a random number. Confirm it in your MetaMask, and that transaction has been finalized, right? But it has not, it could possibly not yet be fulfilled. So let's check. Okay, yeah, so it has given us a latest request ID, but has it been fulfilled? Yes, it has actually been fulfilled. So let's get the latest random numbers. Of course, it gives us the random numbers. So you can see that it gives us an array of 3 strings, right? That is the first one. Here is the second, and this is the third. So these numbers are generated on chain and cannot be predetermined. So for a developer, you can then decide that you want to get the first number returned from this string, or you want to get the last number returned from this string to use as your random number, or if you want to have any other very specific request, either to return numbers that are within certain ranges, right? So this is how you get your random numbers from the random number generator smart contract, and then you can go use it in your project. So like a coin flip or like a dice. Take for instance, you take the first number in the array index and you set a condition that if it's larger than 5, you can round it up to 1, and if it's up 6 to like 5 to 9, you can round it up to 1. Then if it's 4 to 1, you can round it down to 0. So that gives you a 0 or 1 condition, right? So this is how you can get random numbers to ensure transparency and fairness in your smart contracts. Thank you. And with that, we have come to the end of today's lesson. Thank you for watching to the end of this video. Kindly leave your questions, comments, and feedback. You can also ask your questions on Discord in the dev channel. I'm always available to answer. Like the video and subscribe to the channel. See you in the next one.